All right, this is week 6 going over bitwise logical beginning of classes this week. So first of all, the reading for this week. You got chapter 11 for practical C++, chapter 13 for modern C++. Solo learn this week is more on classes. Kahoot is a challenge. I did add points this week to make sure everyone takes the challenge. So uh, open up your app, iOS or Android for Kahoot, enter in the PIN, accept the challenge, take it, and then submit your name when you're finished with the challenge. You will get 20 points for just completing the challenge. So you will not be graded on right or wrong answers. You'll just be graded on completion of the challenge. So make sure and do that. All right, first thing we're going to look at is the examples for classes this week. We're going to be covering classes next week, classes as well. We're going to look at some examples in Solo Learn. Or some definitions, and so we'll learn some examples. Then we'll look at 3 class examples. We'll go over your assignment and Replit, and then we'll be done for the night. So make sure to do your reading before you attempt anything. Also do the go through and do the solo learn for this week as well. I suggest doing before your assignment as well. So we're going to cover these 3 in classes and solo learn. Solo learn has not only way to learn coding language or refresh yourself, but it's got some pretty good slides on it as well. So we're going to do this. What is an object? What is a class? An example of a class. The first thing it talks about is the object, what an object is when it comes to classes. Object-oriented programming, or OOP, is a programming style that C++ is built upon. Also, Visual Basic, J Sharp, PHP, Python, just to name a few. And basically, it's a programming style is intended to make thinking about programming closer to thinking about the real world. And programming objects are independent units in which its own identity. Each object has its own identity, and these objects, as objects do in the real world. An example it gives is an apple as an object, so as a mug. Each has its unique identity, and it's possible that 2 mugs that look identical are separate, unique objects. An object also might contain other objects, but still, they're still different objects. Objects have what's called characteristics that are used to describe them. For example, a car can be red, it can be blue, a mug can be full or empty, so on and so forth. Characteristics called it. These characteristics are called an attribute of an object. An attribute describes the current state of an object. Objects can have multiple attributes, like a mug can be empty, it can be red, it can be large, it can be small, so on and so forth. An object state is independent of its type. A cup may be full of water, another cup might be empty. In a real world, each object behaves in its own way. The car moves, the phone rings, so on and so forth. The same applies to objects. Behavior is specific to that object's type. So the following 3 dimensions describe an object in object-oriented programming language. Object can be described as identity in a dimension, attribute in a dimension, and behavior in a dimension. So 3-dimensional objects, identity, attributes, and behavior. So objects here, when referring to programming, is self-contained with its own identity, and it's separate from other objects. Each object has its own attributes which describes itself in its current state. Each exhibits its own behavior, which demonstrates what they can do. So an example here is person object on the left named John, age 25, talk. Person object Amy, age 22, also talk. And these are behaviors. Talk will be the behaviors. Car object is red, 2015, but some of the behavioral attributes start, stop, horn. So when it comes to computing, objects aren't always representative of physical items. For example, a programming object can represent date, time, bank account. A bank account is not tangible. You can't see it or touch it, but it does have well-defined, it can be a well-defined object, has its own identity, attributes, behavior. So we'll look at some examples here of some classes. We're going to look at the abstract, C practice, and declaration and use classes. So first is this one, the C abstract. So an abstract class is indicated by the declaration of a class. And so you basically, it's going to be a class name of some type. An abstract also, abstract method is a method that is declared but contains no implementation. An abstract class may or may not be initialized. It requires subclasses to provide implementation. The way this concept expresses C++ is to have a member function declaration assigned to 0. And so in a abstract, you'll always have it equal to 0. That abstract class will be. And so an example of a class, pure abstract class, public virtual void abstract member function equals 0. So in this example here, we have class A and class B, and then a main. So let's start out here in the class A. You'll notice a public virtual integer f. Inside of it is a variable argument int x. Cout a dot f is whatever x is. If x is equal to 0, return g. Else f x minus 1. G, you'll notice, is also built into the function A. In class B, it also encapsulates and brings in A as well. And so in this one, it's B dot G. It's actually from here on the line 24 and returning it. So if I go ahead and run this as it is, A dot F 3, then 2, then 1, then 0, then nothing. Okay, it keeps going back and forth on that, starting out with the largest on the 3 and working its way down. And so you'll notice it starts with 3, so we change this just to show you, and we'll go on the code and look at it. 5 all the way to 0, then nothing. So again, when it goes to B, new B, we're actually asking it to go to the B class, which also has the A class built into it. It brings in B into that, because you'll notice here it's actually pointing it to the F. And it brings in this value here. The first cout is A dot F. It's going to be 5. Goes back to the next one. And because it's going to be the first one. All right. First one is not going to be 0 because X is not going to be 0. X is going to be 5. So it's going to go to this path here, which is going to be 5, -1, is 5 or is 4. And then it's going to come back to the cout and display that. So a.f here on the first one is going to be 5. So this here. Next, when it comes through, it's going to come down through this loop. It's going to decrement it by 1. And it's going to return f, which is going to be 4 now. Okay, it's going to come back to the main, return again. A.f is 4, decrement it by 1. Then back to the main again. Keep going back and back and back and forth. Basically, what it's doing here is calling this over and over again until it gets to 0. When it gets to 0, which is going to be at the a.f call here, it's going to get to 0. Then notice return G is called. Return G is going to just return an empty quote or an empty bracket. And you'll notice in that G here in the public is just a cout G. And so basically by doing this, we're encapsulating the abstract class within a class. Public B or class B encapsulates A continually throughout the app. And so when it's called, it's going to do such. And it's also, you'll notice, referencing in that the virtual class F. That's why it's being called to the F function initially. When it finally gets to 0, it's going to be coming back to B, which is going to give you the cout finally, which is B.G. Next is the practice classes. A little bit more in depth on classes here. This one has a class called animal, dog, and a void class called animal as well, with say hello. So let's look at the main. First is taking animal class and renaming it to animal, meaning, or not renaming it, actually becoming a part, declaring it as something else within the main. So animal itself now, the class animal, is going to have that variable or that object within it. Then animal.sayhello is going to be called. It says hello, I'm an animal. And then dog is being declared as the word dog. And notice it is actually also bringing in the constructor for animal. So you have animal saying hello, you've got dog saying hello. Both of these coming from the same class, technically, being called in different ways throughout the program. Let's go ahead and run it. So constructor of animal, hello, I'm an animal. Constructor of an animal, constructor of a dog, hello, I'm an animal. And so first call, animal. We'll call out the constructor, I'm an animal, and then call the hello, which says hello, I'm an animal. Then animal.sayhello says hello, I am an animal. A constructor of an animal, and then constructor of a dog is going to be next. Also saying in that here, after constructor of dog is called, it's going to go to the hello one for dog, which is actually going to be declared here because say hello is now part of dog because of this public animal. So if we were to put something different in here just to show you, like constructor of dog 2, constructor of animal 2, and you'll see how it's called or where it's called. And the dog is called actually when it's first defined here, because without this, this wouldn't work. Okay. So if we basically commented out this line here and tried to run this, you'll notice animal 2 is called constructor of animal 2, hello my animal, and then say hello, hello my animal. Then dog is called. But notice because I took this out, it's going to skip back to this first constructor, animal 2, and hello I am an animal again. Bring it back in. All right. And so this is what's called a class within a class, or construct within a construct class. And then declaring using classes. Here we've got a class called add. Inside this add class, you have the public as always for your classes that if you're going to use it throughout the app. Couple integers, x and y, and then a function within the class called sum that does a return of x and y. Inside the main, we're redefining the class and calling it calc, telling the user to enter number 1, and then seeing in the x variable in add, seeing in the y variable in add, and then calling the sum function. Let's go ahead and run it. Enter number 1, 3. And so far we only have y, or x variable has been called. Enter number 2, 4. Y was called and then declared. And then finally, the sum is calc.sum is going to sum it. And what you're going to do for your exercise here is I want you to create a function within the add called mult for multiply, subtraction for multiplication or for subtraction, and division, div for division, and subtr for the subtraction. And then in the main, you're going to call those, the calc or the calculation is, the subtraction is, the divisional is. And then it says here to run the app for 30 and number 1 and 10 for number 2. And you can do whatever else you want to in that as well. But what I want you to do once you've created this exercise, in week 6, there'll be a assignment link for in-class exercise that you will submit the URL of this replit. So once you're finished with your example, you'll click the share link as always. Once you click the share link, it'll create one of your name. Mine's C. Conkle, but it'll be your name. You'll share that and copy that and paste it into week 6 in-class exercise assignment. All right, so we went over the Solo Learn, went over the 3 example links. This link here is a book I put in here because it is a GitHub book. I recommend just a reference, really, another good reference. And the reason I like this was I'm into drone programming, and this was actually built. This tutorial here, this book, this Git book, basically was created to show how this uh, called a Beagle Bone Development Board was used to develop 36 sensors for real-time analysis within the drone technology. And it could be used in, robotics and people, people using robotics and also drone technology. So anyway, it's just a link for some more examples. It does have a section that's good on a little bit more different slant and functionality for classes, which I recommend going over as far as the examples they give of classes and how they're utilized within the program here for the drone. But again, it's just another example for coding for classes. Kahoo, we already went over. Already did the examples. Okay, let's go over the assignment. It's going to be chapters or lesson 6 is what we're going to be going over. And let me see here. I've got it here. So in this one here, you're going to write a class called rectangle having 2 public variables, one member function will return the area of the rectangle, and declare a variable as rectangle to cn length, width, and then return that area. And you're going to use and declare class as we've been doing in this week. So the outputs should be something like enter in the length of the rectangle, you put 12, width of the rectangle, you put 12. It's going to return with the area 144. Here's an example of somewhat what you'll be doing like we went over in the in class already for the in class, except you'll be doing yours for area. And this example here is done for, I believe, sum. And so, but it's going to be the same type of app. You'll just be tweaking it for the area app functionality. All right. And then, as always, you have your review questions. And lastly, your discussion. All right. So that concludes week 6. If you have any questions, shoot me an email. Otherwise, let's have a great week.